Thank you everyone for joining today's webinar from Push Technology and Axual. My name is Joey and I do the marketing at Axual. So today, Richard and Dave are diving into dynamic personalization of financial data streams. And I know they have been discussing this subject over the last few weeks and they've come up with some interesting insights. So I can't wait. But before we get started, I wanted to say that this webinar will be recorded. So everyone will receive the webinar recording afterwards. And also we do have a QA session at the end of this webinar. So if you have any questions, feel free to submit them into the QA box. Now I'll make sure Dave or Richard provides you with an answer. Okay, that's it from me. Let's move over to Dave and Richard and get started. Go ahead, guys.
Thank you, Joey, for that introduction. And let's move to the content of the webinar. In this webinar, we will be talking about the challenges with financial data streams and how Diffusion and Axual offer their tooling to solve those challenges. At the end, we will have a live Q&A. If you have questions, you can put them already in the Q&A section. We will answer them at the end. So first, for our challenges, financial data streams have some generic challenges. There are a lot of events being published, a lot of data going through. Often you need to guarantee the order of those events in transactions. You don't want a transaction overtaking another transaction. But also you have multiple event types that can come through a single channel. That this is something that is happening with external providers. They don't know which channel you're using, so they just put everything on one channel. Also, events can be quite big and you want to control access to all that data. And in a lot of cases, you want to persist the events so you can do replay, go back in time, or when you have consumers for events that are not yet online, they can catch up with past events. So Kafka is one of the solutions and it provides handling for those high volume events. It was designed for handling those volumes and persisting the data to the local storage. It has a guarantee for your event ordering. You can control if you want to use that. So it is not a forced guarantee. You can improve performance by disabling this for your producers. It contains centralized publication points, called topics, and they are usually created with a single use case in mind. Think about new customer approved, fraud detected, but also maybe for HR, employees' birthdays. And it can control each of those publication points, the access. So you can say, I can read, you can write, someone else can't even see that it exists. So it has a fine-grained control up to the publication point. This leaves a couple of challenges still open. That is the last mile events. If you have a system outside of your local network or your wide area network, you need to go over the internet. Then the Kafka protocol isn't the most internet friendly. You need quite a reliable network to get good latency and throughput. Mobile web feeds and website feeds are an example that you don't easily do with Kafka. There's a lot of data going through and you need to filter at the end of the mobile app and the website. So you even can get too much data that's not even needed. There's also the issue of restricting access based on content inside the event. This is event streams versus data streaming, as we call this. Event streams is basically, I've got an event, it has a data format, and each event stands alone and has its own purpose. But the event itself consists of lots of fields It can have many layers, can be very complex, and contain different types of data. If you have confidentiality restrictions, you might want to filter that, restrict access based on the content. I don't want you to access any event that is not about you. Well, you can do this in Kafka. With the streaming solution, you split it, but that means you need to create a new topic that needs to be persisted to disk. So it is an extra load on the file system. In small scales, that works, but when you scale up with these kinds of filtering, add more filter rules, you need more topics, more storage, and you need to expand your cluster to handle all that data. The same is true if you want to restructure your event because it is not useful or it is too verbose in the current format. But I am not interested in storing it. I just want to transform it and use it. If we use Kafka, we need to use an intermediate topic again, publish the new form on that topic, and then the consumer can pick it up. Again, giving us a massive growth. So how do we maintain our Kafka cluster clean and address these challenges? So let's first introduce ourselves and our Push Technologies and Axual, and then we'll get into the real the use case and how to solve this. Over to you, Dave.
Thank you, Richard. Hi, everyone. My name is Dave Carson. I've been at Push for 2 years, and a little bit about Push Technology. Push has, for over 15 years, been a pioneer in the real-time event data streaming space. We operate across industries, with finance and e-gaming being two of our biggest industries, but we're also in transport and many other industries. A sample of our customer base includes the CME, Credit Suisse, and TP ICAP. Our core platform, called Diffusion, provides what we call low-code processing of event streams. So low-code means no need to actually write code, and the processing of event streams mean that we can integrate event streams, we can transform them to create new value, and we can distribute them as efficiently to a global user base. And we can do this extremely quickly, on demand, in real time. So we can integrate data from any source, we can transform that data inside Diffusion as we need to on demand, and we can securely and efficiently distribute out to the world. And I look after the field architecture and services side of things at Push Technology. Thank you, Richard. Now, a little bit about the benefits that Diffusion brings to our customers. So we have found over the past X amount of years that our customers, they will see a reduction in their infrastructure costs, but also the end-to-end latency as they're moving these events through their platforms. Diffusion will actually end up in a reduction of latency as the data flows through the multiple layers of their platforms. We have also seen that our clients are able to bring new applications to market much faster with a better performance. They are also able to control access to the data with a much more finer granularity. As we'll see later in this presentation, we can control access to data down to the finest detail. As a result of these, we find that our customers in finance and e-gaming have seen improved matching rates, if you like. They're also able to gain access to an increased number of markets, and they're also able to offer new markets to their customers much more quickly than they normally would. Next slide, please. And this is just a little bit about how Diffusion can achieve these objectives. So essentially, Diffusion is made up of the 3 layers that we see in the middle here. The first part is what we call our data gateway, which allows us to integrate from any data source, any source of data from any protocol. We will see a little bit more on the gateway shortly. We also have then what we call data wrangling. This allows us to transform and add value to the event streams running through Diffusion. We can create custom views on the fly as we need to meet our customer needs. And then we are able to securely and very efficiently distribute this out to a global user base anywhere in the world with very fast performance, usually single-digit milliseconds, but even around the world, a sub-second. Now, it is worth highlighting one point here for me, that Diffusion can be deployed in the cloud, any of the clouds. We also have our own cloud offering. It can be deployed on-premise, and we have customers who have a hybrid of both cloud and on-premise deployments. Thank you, Richard.
Thank you. So I'm Richard Bos. I started at Axual in 2017. Axual was founded around 2015 to provide a Kafka-based event streaming platform. The experience back then was that Kafka is easy to maintain when you start, but when you start to grow, you've got more people using it, more development teams, it becomes a lot harder. So the common issue that we see is either a single team maintains Kafka and does all the administration, to creating topics, creating access rules, but then they become a bottleneck for development teams. There's no quick getting started with Kafka for them. The other way around it is to give each development team access to create their own topics, create their own access control. But that means that you often have no uniform approach in naming, access rules, all those things. And this will give you can give you governance issues. A lot of companies try to build their own scripting, their own tools for this. We decided to create a self-service component where we put the governance in the hand of the business mostly. So we take stream and data ownership. We have application ownership. They are teams that are responsible for the data, the events, and the other for the applications processing them. It also makes it possible to run multi-tenancy environments on single Kafka clusters because we control naming and can control isolation from that point forward. And we can manage multiple Kafka deployments at the same time from a single web service interface. I'm one of the architects, and I've recently started as the developer advocate within Axual. And Axual is currently now in use with Stedin, Rabobank, Inexis, so in banking sector and in the energy sector. We've got quite a lot of customers and growing. So I've talked now about Axual and Kafka. What Axual is to Kafka, what Red Hat is to Linux. We add functionality, we combine them, give our own way of governance on top of that to implement and control a Kafka installation. We've also got, see it in a triple level setup, different kinds of maintenance. The lowest level is the infrastructure where you can run it. That is your data centers or a Kubernetes somewhere in the cloud. It can run anywhere, but that is a separate responsibility. Then we have a technical level, the streaming platform, which contains Kafka. It contains tools to make sure that Kafka clusters are in sync and are available. They can be maintained by a specific group of people and maintainers. And then we have the functional part, which is really the data governance. And then we're talking about topics, schema definitions, application and application owners, authorization rules. So the actual platform focuses on those top two layers and is designed to work on any kind of infrastructure that is available on-prem, cloud, hybrid. That's our customer's choice. The self-service, we'll get to that soon, but this is a screenshot for an overview of an environment where you see multiple producers in green and the streams in white, the topics. Now let's go into the use case that we want to that we've devised for this webinar. Maduro Bank, a fictional bank, and like most banks, they have quite a classic setup: messaging engines, mainframes. They know that that is really reliable, but not usually the most flexible, and they want to move to an event-based architecture. Well, during their research, they already found Kafka, and they also selected it as to be their core technology. And they created a first use case where payments are being produced as an event. Alert settings are actually produced to the eventing platform, and there's an application streaming that data, so reading those events, combining them, and if needed, sending out alerts on as a specific event, which will be picked up by a data lake and a notification service that will send it to mobile phone, email, give you a call, or whatever line is available. But they also already know that the adoption rate will increase. It will be a slow start, few topics, but it will grow, and it can grow quite quickly. So, and then you need to manage a lot of topics, consumers, applications. They want to standardize their approach in this event platform, which means quite a lot of usage. So how does Axual help in this? Well, like I just shown you, there can be a single team maintaining the platform itself. So Kafka, event, the user interfaces, while the functional deployment, defining topics, defining applications, can be done through self-service. This will improve your governance. Just a second. So I'll just show you now how that looks like. We've created an installation for Maduro Bank, and I am one of the users and actually one of the administrators at this time. Oh. So normally you arrive at your dashboard. If there are actions open for you, you get a list of your pending actions. And this is the current view, what is set up. So we've got at the left an alert settings loader that is loading from a database to a Kafka compaction topic that is defined here. So you see here the name of the topic. You get descriptions. You can see who the owner is and whom you need to contact if you have any questions. You can see underneath where it produces and consumes. And here we have a configuration of your topic. So in this list, I can put custom properties. I can set retention time. Every change I make, if I now change this one to 1 hour retention, that means that messages will be deleted after 1 hour. I've saved it. Right now, the retention has been set on all affected clusters. I also, as you can see, we're also still lacking the data lake. And I wanted to show you how to create a producer, or at least how to request access. So this is the data lake feeder. And I've already configured it to use a certificate to authenticate on the server. And I can do an add request, consume, and then I want to read the transaction alerts on the production environment. request approval. At this time, I cannot consume yet because the owner has said, I want to approve all requests. Well, I am also the owner of the stream, the data owner. And in my view, you can now see that Richard was request access for this application. I approve. Right now, my consumer can be activated and read data from that event. And in the overview, you will now see that data lake has been added as well. So for Maduro Bank, we now have these current topics with the data lake connection. And Maduro Bank is now active with their installation. So this entire installation is now running with the event platform Axual, and everything is configured. For our use case, we want to add foreign exchange updates. There's a third-party FX update producer. The data that we are using here, the quote data, is provided by tick data. And we've added a second type of event, the trade data based on the quotes, to demonstrate how you can personalize this view. All these two types of events are sent several times per second, currently at around, well, I think 50 requests per second hit rate on a single publication point. The quote data, so to the left, you'll see that it has a contributor, it has a region, of course, a type to identify what kind of data it is. It's got a pair name for the foreign exchange. So this is euro and US dollars. And at the trade side, it is a trade for a specific pair at a specific price. So we have defined what we want to add for an exchange, and we have defined an FX supplier, which is outside of the company network. But we want to also reach mobile applications. We want to have in our mobile app or on the website that I can select. I am only interested in the euro transaction, in the euro trades, or I'm only interested in the euro quotes. So we put diffusion at the edge of the one. It's drawn at the edge, but it is inside the network, behind the firewall, and the application can connect from the internet to diffusion, and diffusion can connect to the internet the same way to provide data. So how do I add diffusion then to Kafka? Well, basically, as any normal application, you create a name, you register it in Kafka as a normal client application, and give it the right access, so consumer or producer, or both, depending on which, if it needs to produce and consume on multiple topics. If I go back to Axual, I've produced in a different environment this setup already. So here you see both the existing payments setup and now also an FX loader, which goes to the FX updates, and it goes to it goes back to diffusion, which can load to other topics. So there's a real stream of events going on. And in the last hour, we produced 280,000 messages. So right now we've got data coming in, and we've set up Kafka with the proper ACLs with full control into to use the data produced on Kafka. Dave?
Thank you, Richard. Yes, so whereas our demo is focused on foreign exchange data, it is worth just mentioning that Diffusion will support all forms of messages, so including other asset classes like equities, derivatives in the form of futures, options, swaps, and so forth. We also support fixed income, commodities, and even likes of energy markets, cryptocurrencies, or IoT data streams. Essentially, any form of data can be processed through this solution. And if we move to the next slide, we'll just do a quick recap of the challenges with financial data streams. So we're just going to walk through these 3 challenges, and we will illustrate how Diffusion can help solve these, enhance the Kafka solution to solve these 3 remaining challenges. So if we look at the next slide, we will have a quick look at our Diffusion Gateway framework. So the Gateway framework essentially includes all of the boilerplate code that you would expect to build any adapter for any source of data. So essentially it provides consistent configuration, an easy upgrade downgrade process, horizontal scaling as volumes increase, consistent logging and monitoring, and also real-time administration for operational support. Every adapter should look the same. All our clients need to do is build their business critical logic into the adapter, and the Gateway framework will do the rest. It means that our customers no longer have to focus on tightly coupled applications. They can instead build scalable platforms instead. And the demo today is using the Kafka adapter built using the Gateway framework. There are others available today in the form of CDC for database integration. We have a REST adapter and a CSV adapter, and we have many more adapters in the pipeline. If we go to the next slide. So we're going to have a look at FX data in Diffusion. Now, as Richard's already mentioned, in this demo, we're using quotes and trades, but any type of message can be supported. So we could have orders, security status, reference data, any message whatsoever on the wire can be consumed into Diffusion. And I think if we have a look at the console.
So this is the topic browser in the Diffusion Management Console. And in here you can see the raw data coming in. So this is one of the recent messages. And I can actually subscribe to this as well. So in here you can now see actually the data flowing through.
Yeah. So what we're showing here in Diffusion is essentially one of Diffusion's most powerful features is what we call topic views. And what we are doing here is topic views allow us to disaggregate data, like take arrays apart. We can filter data. We can combine data into a single view. We can also change the delivery mechanism of data. So we can add throttling, or we can delay data to provide different levels of service. But the crucial point is that we only need to deliver the data that our clients need. And this example that we have displayed here is the topic view rule is highlighted in red. And all we are doing is we are using the pair name to create a different view. So we can break apart the feed into individual pair names. And then this allows us to permission clients to only certain pairs and so forth. And so they only need to receive the data that they require. And it is worth mentioning in the next slide, we can see this with these are quotes, and then here we're doing the same for trades. So we've also got other rules where we're breaking apart the different messages. So as Richard has highlighted, we have a single feed containing all the different messages on one feed. But with Diffusion, we're able to take these apart so that, for example, applications that only need trade data, they only need to receive the trade data. Now, it is worth mentioning that Diffusion, in the most latest version of Diffusion, we have added a new topic view feature that we call process. And the process transform essentially allows us to perform calculations or conditional logic, which allows us to create new values based on the input data, and then it is added to the output data. We can create new fields, we can remove fields if fields should be taken out, and all of the enriched data can be republished back onto the original Kafka stream.
So I will open the topic view so you can see that there are multiple views created. And here you see the specification that Dave has written to create a view and load this into the currencies. If I go to browser, I've got here currencies, and you'll see all the different currencies. And if I subscribe to topic, you'll see that these will only contain the Euro USD.
Okay, thank you, Richard. So taking our challenges, we've shown how we can restructure the real-time events without persistence. So now we'll move on to the next challenge, which is securing access. So we look at securing access from different angles. One of the first ways that we look at this, and it's another very important feature of Diffusion, is the ability for us to deliver personalized data. And we do this through one of our features that we call session trees. So when a user establishes a session with Diffusion, properties can be defined on the session. Now, this can be done on the server side, or this can be done on the client side. It could be done on logon or session establishment, or it could be done in real time. The server ultimately holds control over what properties are allowed to be defined. So from a permissioning perspective, it's the server is always in control. But these properties can be defined, and there can be many rules defined, allowing for essentially catering for a global audience, but all centrally managed from a single server. Now, these session rules, it's worth highlighting, are also programmatically accessible, and they are subject to permissioning, which we'll cover next in the next slide. But with this particular example, with the rules that we have defined, we see the source branch off to the left of regions. So anyone subscribing to regions that has a property which includes these country codes, their subscription will be routed to the regional, their respective region in which they are coming from. And we can show this in the Diffusion console.
Sessions. So first, the session trees. This is the definition that you just saw. Dave, can you explain a bit what we're seeing here?
Yes, so it's anytime a session is established, which is making a subscription to a bunch of regions, and the session has a property where the country property, dollar country, is set to be either any of these country codes, then the Diffusion server will route the subscription to the resulting topic tree branch. So you could have a global user base subscribing to the regions topic, but Diffusion will route the respective subscription to the destination branch accordingly. This allows one central server to cater for a global audience. It could be, for example, different presenting data in different languages, different currencies. It could be presenting different brands of data from a single server.
Okay, and then we can show here that there is the regions, which is the raw data, and the regional, there is just the global, the euro, it's split. This is where you get directed to when you, from the outside, connect to regions.
Exactly. So anybody coming in from the EMEA or Europe region will be directed to the EUR region, and this will only contain data from the region of EUR.
Any other rules you want to show?
I think on this slide, I think back to the presentation, the core content of this is about delivering personalized data. And it's worth saying that we're showing one property here of country, but we can define any properties whatsoever. There's no inbuilt list of properties. It's up to us what properties we define. We will then just make sure the rules are handling the data accordingly. So we can have any properties we want, but the core feature of this is to deliver personalized views of data to your clients.
Okay.
And if we move to the next slide, we'll have a little bit about how we secure access. So in securing access, all data within Diffusion is subject to IAM permissioning, which is Identity Access Management. IAM is a framework of policies and technologies to ensure that each user is granted the right level of access to the data, not too much, just the right amount. This is achieved through different permissions, which can be applied on a per topic basis or a per topic tree basis. The select right means that the user can actually see the data, otherwise the data is invisible. Read allows them to subscribe, and update will allow them to publish to that topic. Now, it's worth mentioning that roles can be created within the security model, and roles can be aggregated. So we can create a kind of a domain of different users with different permissions set. And that means that we can make it very easy to govern a global user base, perhaps like across many different countries and so forth. Now, within Diffusion, all features must be permissioned. Any attempt really to do anything within the server must be permissioned, but Diffusion takes a least permission wins approach. So this will avoid information leakage at all times. And the final point to mention on this slide is that all permission changes take effect immediately. There is no need to restart the server, no need for clients to resubscribe, no need for any recaching or similar. If a client subscription is subscribed to a topic but doesn't have the permissions, and the permissions are granted, then the data will just start to flow immediately as soon as it's applied. Similarly, if a client is actively subscribed to data and the permission is revoked, the data will stop flowing immediately as well. So if we move to the next slide, and then a little final bit about securing access. Everything we've seen around the identity access management is also API driven. So it can be, the whole model can be populated by APIs. So we have the concept of what we call authentication handlers. An authentication handler takes receipt of a logon attempt, and it can then integrate with any internal or third-party platforms. So this allows our customers to essentially centrally manage their entire user base in their existing systems. And Diffusion will just sit alongside, take receipt of a logon request, and poll the existing system to see if the request is allowed. Integrations we have performed in the past with other customers will include things like Active Directory, single sign-on, OAuth, Kerberos, and even internal JSON Web Token systems as well. We've even integrated with third-party vendors like Okta and Auth0 as well. And there are three outcomes of an authentication handler. It either allows the request, which means the data will then proceed to flow. It can deny the request, meaning it is rejected, or it can abstain, which means that these authentication handlers can be chained together to allow multiple lookups across different systems. Now, just the code off to the left just shows you what an authentication handler looks like. The only code that our clients have to populate is the code in blue in the middle. What is required to allow this request? The client can define that and then allow the request to go through. Otherwise, the request will be denied. And the final point on security that we just want to highlight is Diffusion publishes data over TLS 1.3, which is today's most secure standard. So this means that internet delivery, web delivery, and so forth is completely secured. And furthermore, the ciphers are configurable. So the sysadmins of Diffusion can disable ciphers and so forth. If they become vulnerable in the future, they can be easily disabled. So this essentially future-proofs a Diffusion deployment should the security landscape change in the future. And so this then has addressed the security aspect of Diffusion and Kafka, and how Diffusion can assist with the Kafka deployments by securing the data. And if we then move to the final one, which is data last mile events, so data delivery. How does Diffusion assist with the data delivery over the internet? So Diffusion can publish to clients via different methodologies. It can be pub sub streaming. Pub sub streaming would include things like long polling for clients that are in unreliable networks and so forth. It also can supports request response, so for like messaging and so forth. Based on the client needs, data can also be delayed if that's required, or it can be throttled. Maybe they don't need every tick, maybe they just need one tick every 5 seconds or something similar to that. So to give you an example of how we can use this functionality, so using actually one of the session rules, one of the built-in properties is the principal, and Diffusion supports the ability for anonymous users, that's users that don't actually have a login, they connect to the server with an empty principal. And what we are able to do is we are able to catch the empty principals, and we are able to route them to another view of the data, which is a delayed currency. And then in step 2, we have created the topic view, which is just mapping our currencies tree that we saw earlier, but we map it to a delayed tree, and we delay it by 1 minute. And I think we can view this on the console.
So here we have the principal currencies delayed. Yeah. And then we have the topics and then topic views. And this is the currency delayed. And then in the browser, I can subscribe to the normal currencies. I'll take Euro USD again. Did it? Yeah.
Yep.
And Euro USD in the delayed as well. If I go to subscriptions, I will now open them. And you'll see in the timestamp, the bottom is the delayed one, the top is the current one. And you see that there's a 1 minute delay in those messages.
Yeah, thank you, Richard. And ultimately what this is showing is how through delaying and throttling of data, we can dynamically create new levels of service for our clients based on the client needs. And the final point that we would mention on data delivery then is that Diffusion publishes the deltas, i.e. only what has changed over subsequent messages. Now, these delta calculations, they are operating at the CBOR layer, the concise binary object representation layer, and that means that we can calculate deltas over all topic types. So that includes JSON, even binary and time series data as well. Before the deltas are published, they are compressed, which will further reduce the bandwidth. And Diffusion has an API actually for defining what we call metric collectors for monitoring all types of metrics across the platform. But there are a set of existing metric collectors already defined, and we have a screenshot here of one of these. So we can see the delta compression ratio is 69.52. So that's almost 70%. And with an almost 70% in reduction in bandwidth, that means that for every 100 megabytes going into Diffusion, only 30 megabyte needs to be published. So that's a significant reduction in bandwidth. And with that it covers the last challenge with financial data streams, the last mile events. And that takes us essentially all 3 challenges. So at that point, I will pass it back to you, Richard.
Yeah. So right now, Maduro Bank is set up with a diffusion that feeds external system. The eventing platform has an external foreign exchange supplier that sends data to a data lake. And in Diffusion has also taken up an extra role. And they are, I think, in the quotes. If I now send this back, you'll see that in the last hour, I received 230,915 items from Diffusion, which has filtered the quotes and produced it back to Kafka, completing the streaming cycle and contributing back into the event platform. So we will now be taking questions in the live Q&A. We'll be online to answer them. Joey is going to take over and handle the questions, ask them. If you want to try out Axual and Diffusion, you can go to the websites and sign up for the trial environments for Axual and a temporary trial environment for Diffusion. And thanks for joining, and we're curious in what you think.
Okay, good stuff, gentlemen. Thank you very much for this presentation. It's time for the last part of this webinar, which is the Q&A. Let me open up the QA box to see if people have any questions. Okay, so I see your first question. I think this one is for you, Dave. How can server instances be monitored for day-to-day operations?
Okay, thanks, Joey. So as I mentioned earlier, the Diffusion framework provides an API, what we call meant for defining metric collectors. So essentially any data point whatsoever can be defined by our clients as they see fit and registered within the framework. But it is worth mentioning that Diffusion does come with a suite of existing metric collectors already built in. And I think if Richard has the console, I think we're able to show this, just some examples of what is already off the shelf within Diffusion. So if I'll pass it to Richard if you're happy to bring up the console.
Yes, I'll share the. And do you see the console?
Yes, yep. Just on the overview tab. You will see. So here we have everything around this is off the shelf. It monitors topic data, it monitors system metrics, like as in disk space, CPU, and so forth. It will even monitor things like the Java virtual machine. Here you can see with this demo, we're only using under 200 meg JVM and so forth. So with all the data that is currently flowing through Diffusion, there is a very, very small footprint on the actual system itself. And then Richard, if I may ask you then just to flip to the topics slide and then just across to metrics. Again, we will see this is a live update of the data flowing through Diffusion of all this FX data, and we're still seeing just slightly under 70% delta compression ratio. So for every 100 megabytes received from Kafka, only 30 megabytes needs to be published. But clients can define their own metrics as needed. Hopefully that's okay for an answer.
Cool, thanks, Dave. See another question coming in. This one is for you, Richard. What kind of security does Axual support, and can we use existing authentication systems?
A good question. Our systems are using TLS 1.3. It can fall back to 1.2 should you have clients that aren't capable of connecting with TLS 1.3. For authentication purposes in our self-service, it can be connected to a lot of different systems, OAuth based, Active Directory, Google Authentication. We based our security on via Keycloak that acts as the federation service. So you can even say I've got two different systems, an Active Directory and a Google Authentication, and they can use either one for a single tenant. Okay, thanks, Richard. I see another question coming in the chat box from Shruti. Are there any error logging and CAN monitoring integrated with monitoring tools like Dynatrace or AppDynamics, AppD? I'll start with the Kafka part. You can, with Kafka clients, you can enrich the events with tracing data. Kafka supports headers, so it is not part of your payload, the main payload, but just as metadata. And you can then extract that from a consumer, publish that. I don't know if Diffusion can do that, but Dave can answer that question, I think.
Yes, absolutely. Thank you, Richard. So there is we have worked with our clients to integrate Diffusion's logging and monitoring into existing internal platforms for monitoring, but also third-party vendors. So on a logging perspective, it uses the standard Log4j2. So its scrapers are very easy to come across to integrate with existing systems. But for those that require more programmatic access for actually looking underneath the hood, then we have written metric collectors which interface with third-party monitoring tools like Splunk, ITRS, and so forth as well. So we're integrating with any monitoring tool is, if it's not available by scraping the logs today, it can be, we can code it very simply.
Good that you mentioned that. I forgot to say that the error logging in the Axual platform is also configurable. By default, it writes to the output stream or a file, but it can be connected to log collection systems without with a site reconfiguration during deployment. So I hope that answers this question.
Thanks, gentlemen. I see another question coming in. This one is also for you, Dave. How many connections can Diffusion service on the edge?
Okay, that's a good question. We have clients today who are publishing their data to hundreds of thousands of connections from a single Diffusion instance. So where it comes to the point where perhaps some load balancing is required, we can bring up an additional Diffusion server and spread the load across the two connections, and then use technologies like load balancers and so forth as needed. But today, as it stands, we have single servers catering for hundreds of thousands of unique connections consuming data. And that's fast moving data in the e-gaming world.
Cool. Wow. Sounds good. I think this might be the last question. I guess this one is for you, Richard. I already use Kafka. Can I apply Axual on top of my existing Kafka setup?
Yeah, Axual is compatible as it is based on a normal Kafka cluster. There might be some slight modifications required in your existing cluster to connect the management system to be able to control and collect the data, but that is possible.
All right. Let me see the QA box again. I think we run out of questions, so I guess that's it for today. Thanks, Dave, and thanks, Richard, for the presentation and the demo. I will make sure to share the recording afterwards. You can expect an email from me somewhere tomorrow. So thanks again. Have a great day, and thank you, Dave and Richard.